we support our production area upstairs for memory testing. That's correct. And we have an engineering document control is see the one who build material won't review, make sure the work is correct. That's right. So we do the QA. Today look like not too many people here speaking English. Different training from the cell, right? So I prefer to speak very slowly. So after we'll do the training together with me today. Okay? So let's start with, I want to know what is your job function, what you do, so I can give you the better training. So let's start with this gentleman first. What do you do? What is your name? What do you do? Just sit down, sit down, sit down. Okay. You can speak Chinese. What do you do? You tell me.
你可以说中文啦，他可以知道一些，你可以。
So what is your job function in upstairs? What do you do upstairs? What do you support? Are you test engineer or are you production engineer? Or are you do the job to rework or are you do, okay, so what is your job function? Memory tester. Memory tester. Is that right?
Yes. Yes.
So memory tester. So it's not a test engineer, not an electrical engineer. Okay. I got you. How about you? Huh? What it is?
His name.
Your name. Okay, nice to meet you. Okay, what do you do to support? Memory tester. Okay.
My name is Pakistan.
Okay.
My production engineer.
Production engineer.
Yeah.
Test engineer.
Yeah.
Okay. Okay. What do you? Let me say. Let me talk. Speak Chinese. Don't worry. People stand up. Generation. What do you do?
Test
Test technician. Test technician, right? Okay, I know the level. So I know him. Lee. Lee is doing S&P manager, S&P production, and make sure the S&P quality, productivity process, S&P program. So we're going to go over that area too. Okay, to make sure the team work together with the S&P production together, see the process. And you do it sales.
Yes.
Tell me your name again.
My name is Miles.
So, what the reason you are here? You just love
Yeah, I just wanted to learn more from you about the testing process and the other things.
Yeah, that's very nice. So this training is for engineering, but we have to say I've been invited them to come over to attend the engineering training, to find out what we do so they can sell the product better. Ophelia. The guy know Ophelia? Yeah. How about you, man? What is your name? Joey Lee. What do you do to support the company? You create a bill of material and enter into the system, and then for the system you verify, confirm all the components correctly, and then issue to production. Okay. Yes, how about you now? What is your name? Ren? Okay. What do you do? Are you QC or you are QA for the testing area? FPQC, final QC, final quality control. Okay. That's right. Final QC, right? Final QC to make sure every product is shipped to customers correctly, right? So, how about you? Reading. What do you do reading? Final QC. Okay. Mandy, I know him. He's engineering manager. He oversees all the activities for engineering testing. Right? Introduce yourself to the team a little bit.
No manage, supervise.
That doesn't matter as long as you manage the testing, right? So you're responsible what? Manage the testing, production testing, and what else?
No.
That's it, right? Okay. So we have different levels here, right? I'm expecting different training, but now we have different levels from tester, production testing, and production engineer and test technician, and then SMT department. Have some SMT department. We have a cell try to learn the engineering. We have another cell here, and we have this lady is doing bill of material, import and export the ball and verify the ball, and this lady is doing final QC, is final quality, inspection, final QC, and the job is final QC too. See, I have a very good memory. Everybody here, job function I know now. The reason I try to go over with you guys because I want to know what is your job function in the company, so I can perform the training better. I don't want to go too far, and I don't want to go too low. So since we have a combined class, what we're going to go over today is really to show you guys understanding the process, to show you guys understanding about the engineering process from the headquarters, what we do. So for you to know only, you don't have to do it, but for you to know what we do in the headquarters, what we develop the new product. So how we develop the SPD, and how we develop the testing, and how we develop the functional test at the end. So for you to know and understanding. Also, the second thing I want to go over with you guys is compatible motherboard and the SPD device, and also different type of memory. So finally, I want to go over the training with the SMT department and also with QC and QA department to make sure everybody has the same understanding about the job function, what to do and what to support to the company. Right? So first of all, can you open the file and product development? So Number one, do you need the generation? You guys understand? No? I just went over. Oh. It's okay. Every new product, when you see the new stick, new memory, new PCB, new component, new spec, we have to compete with other company. That's why the engineering team in the headquarters always try to find the best device, the best PCB, and the best kits to develop a new product for you guys. I mean for the sale, right? But so after we develop the product, we release to production. So including bill of material release, including testing specification, and including the SOP and how to test and how to follow up after the development is done and release the product to production. So, but today, this is for engineering. I want to share with you guys. It doesn't mean you have to do it, but you have a better understanding what we do in the headquarters. Right? You see at review the marketing spec from engineering side, meaning based on the market, right? Based on the market requirement, a lot of company is talking about the memory, right? The memory is big in the market. 2,400. Right? So as of today, the market for overclocking memory is up to 2,400. It's meaning, so the engineering team need to find a way, find a chip, find a PCB to make it 2,400 to compete with other company. So this is the process. That's how we develop the new product to the memory stick. Okay. So let me go to the detail of the product. So when we got the okay. So we have to generate the PRD, that means PRD engineering commitment what we deliver product specification. It's meaning the target of the engineer is this. So number one, in order to get this spec right, the engineer need to find out A is RAM, DRAM. DRAM spec either from Micron from Samsung or from Naya, right? So, first of all, in order to make this, engineer the headquarters need to find out what kind of DRAM can meet the spec. So that number one, so they need to find out this can be able to build up to 2,400, right? Can build up to 2,400. Seven. So B, we need to have a PCB. Right? Let's say this is the target of 2,400 is the target for the engineering. Right? A PCB spec. That means, this PCB is 6 layer. Something like that. Okay. C. MB compatible. Okay. MB compatible. So they treat them. So when we have all this information in the package, right? Go up more. Okay. This is how we release. We have to do a prototype, right? We have to determine to build a product or product development requirement. Which means either we're using the exit PCB device, what needs to be done, develop the product, not including retail package. So number one, the DRAM is the RAM screen required for hit target spec. It's a RAM screen required for hit target spec. That means if the RAM, we have to bring down the frequency. We have to bring down the frequency. Evenly, every RAM the same. So we can meet the target spec. This is the target spec, right? Right? 2,400. So assume this is a new product that we do. So we have to screen the DRAM spec. We buy from Samsung, from Naya, whatever RAM, it can do 2,400. So we screen it, it's been sorted. We sorted out the frequency of the RAM. So in order before we build, right? So it's the PCB device was there already. So now, okay. Engineer ES and engineer sample present at the day production really sample. So this go up more. So when we have all of this, then we do a prototype build. So when we have all the information, we know and we test a little bit, and we know, and we now we try to build a complete module to see if we can meet the targets or not. Meaning we got a prototype build, let's say 20, right? We build SMT, and then test, SMT, and then test. Okay, for QC, QA, process. If everything here okay, and then we move to test, right? So SMT view is either we use single side or triple side, doesn't matter, SMT process. I'm going to explain the SMT process later. So we test. We test it. Not only we test a shoot motherboard, Intel, AMD, and EVGA. We test a lot of motherboard to qualify, to make sure it's compatibility. Right? So, when we test this, if everything is past 2,400, that means the product is done. So meaning, no matter we do, if we fail with 3 tests of this, that means nothing. So no matter HPA take the set marketing, set the target, okay, all the company can build it 2,400. We can do the same thing. We can do the same thing. So this is the little bit process, the detail. So after we get this brand, this PCB, we know which one is motherboard. So we do a prototype build, and then we do SMT and QA process, everything okay. Now we test a shoot motherboard, and we test Intel motherboard, and we test AMD motherboard, and we test EVGA motherboard, and also this time is CPU different, right? So this is motherboard with this CPU. That we call qualification process, engineering qualification process in the headquarters. Right? So the testing including we test open the test this one. Yeah, the IRD test. So, and we're using the RFD test to qualify. That's including burn-in. And look. So, RFD test. After we have to test in order to know the product is good to go, the product that meets all the specifications, the product that meets the specs, 2,400 that is down. But this, we test 99 look. 99 to overnight, we burn the motor overnight, maybe 72 hours, 48 hours. The loop cycle, we put it 99 cycle, loop, test it over and over again. Go ahead and do the demo. So here we go. Let me see, we demo it. Okay. Assuming the process is done, okay. This it can tell us 2,400. But the next step we using the IRT test. Let's see, this is the motor, SPM developer, this is the motor. This is the motherboard, A-shoot, P7, P55. So, all of this is the IRT process now. So, all of this pattern, stop, jump, working with, link, swap. So, when during the qualification process for engineering, we require to test all the patterns. We require to test all the patterns. Gen to 99 loop. Yeah, 99 loop. Every loop, that means this Yes. You get some, get me some napkin. So I'll go into detail with the process for each department. This is for you to know what we do in the headquarters. Okay, you don't really need to do, but it's better for you to understand what we do from the headquarters before you receive the product from us. So this is just a process for the headquarters. You don't have to worry to do this. But this is really for engineering from headquarters. We control the development. We control the new product. This is the process that we do in the headquarters. Yeah, after here. So this software 99 looked at the master. What happened? Why are you laughing? Huh? What happened? Huh? What happened? You have any question? No? It's okay. It's okay, Arthur. It's okay, let's go. So the keyboard is stuck. So this is all the pattern, right? The loop here is 99 loop. Okay, it's for engineering, not for production, okay? Engineering qualification is we call burning. We test again and again. Day number 1, day number 2, day number 1, 24 hours, day number 2, 48 hours, day number 3, 72 hours. Up to whatever requirement. Until we feel very confident. And then we're going to start. So all this development will take a lot of time to select the chip. Take time to select the right PCB. And it takes time to do a prototype build, different law. The prototype build is passed, the test for different motherboard compatibility to make sure, we have the right SPD, we have the right motherboard, we have the right speed. And then the final one, we use the IIT test, burn-in test. So this is all the memory functional test. So when we pass all of this, that means our condition of memory very good. So if we can make 2,000 followers here, real good. What happened if we only 2,300 or 2,200? We failed, right? We failed. When we fail, it means we have no new product to release to you guys. That means engineers have to try harder to find the right DRAM, to find the right thing, to develop the new product, to compete with other companies. So that's what an engineering job in the headquarters. So engineers are supposed to get the new product and develop the new product. The process that I show you, develop the new product and release to production. Right? Release to production. Now it's your time to take over. It's your time to take over. Your time to monitor the new product development from engineering headquarters. So this is your time, like Arthur will take over. My will take over. Am I right, Mike? Yeah. Am I right? So, and you as support, we need to support every single product testing line. And QC need to make sure the quality control. That is how the process works to come up with a new product development. So then you need the test. So let's the next one is for tester, right? So so when we release the new product to the guy, that means the package, right? It's file loop. Select file loop. Go back to the test and select file loop. So when we release the product to production, we release the SOP. SOP meaning, the instruction, the procedure for your guy to follow. Right? When you follow, and you should not change anything when we release the new product. And since we qualify different motherboard, why we select only 5 patterns? Let me explain why. Because we qualify a lot of motherboard, we qualify in our engineering lab already. That's why when we release the product to production, it meaning the product really is stable and steady. So you don't need to duplicate all the tests. All you need to do is just select 5 test patterns. That's usually the best for production. The 5 test patterns include stuck, jump, swap, squeeze, drop top. The 5, depend 5 or 6 patterns for production only. The other test option you don't need to, but for engineering qualification, you need to test all this and you need to test the 99 cycle count. But before production, you only need 5 loops. 5 loops, can you adjust to 5 loops? No. It's okay. You see what the difference of failure? You see, production is only using 5 loops. The engineering, when you qualify the process, you test all the patterns. For production, yeah, for engineering, we test all the patterns. Because engineering, production is only testing only one motherboard. And then only one motherboard is CPU. But for engineering qualification process, we test different motherboard, we test more motherboard to make sure the compatibility, to make sure it's work, the reliability, work for different major motherboard. At least we qualify the different major motherboard. We know we can send the customer don't return. If we only qualify one motherboard, it's not good. We have to qualify different motherboard in order to know how many modules okay to sell. Right? That's because of compatibility. So for the testing, you know about this? Good. So how many test patterns you need to test? How many? 5. Good job. You know how many loops? Can you change it? Can you change the pattern? Change it from
可以改变这些自己的项目吗？
Good. You're not allowed to change anything. Even manual auto. Right, Mike? Even me. Right? Even me. That's the company policy. Nobody can change it unless we have the release document from engineering. Change it. Then you can change. All you need to know for the testing area, we need to test 5 loops. We need to test test five items. That's good enough. Do it to make sure. And it's going to the bias setup. So that's the process for engineering. Okay. Like again, I repeat again by myself. You just need to know and to understand about engineering process, but you don't really need to do it. Then move on to bomb, right? Build a material. So So after we finish engineering, right? Because engineering release to production. So number one, what do we need for engineering production? Bomb can build a material, right? Number two, SPD, right? What about number three? What do you need? Aspect. Aspect means either 2,400, 2,000, 18 or 16 CL 9, whatever, CL 8, or maybe CL 7, maybe CL 6. So call out one is 1.65 or 1.65. Okay, you understand about this? You know this? How about you? You understand this? So when we have a new product finished, right? We release to production, which is informatical. Who want to take over my new? When after we take over this, right? When we have a new product released from Vincent and me, somehow we have a team. So we send a product release that into my new and to Arthur. So the team here, you know, you are production engineer, test engineer. So the thing that you need to verify from engineering department, from build material including what? The most important on the build material, what it does, what is it? DRAM and so and capacitor, resistor. From the bulk of material, including drawing. So when you receive the bulk, what do you do? You give the bulk. Who gives you the bulk? After I give you the bulk. Yeah. So in the bulb here, right? So in the bulb, we need to verify carefully. The project and verify the bill of material is correctly or not correctly before you enter into the system. Because when you enter into the system, the bulb for that product, right? Product release, you know, that's including the bulb, SPD, test spec. So all the team here know this already, but when you enter the bill of material, bulb very important. Yeah? You have to enter the DRAM, you have to enter to make sure the DRAM is what kind of DRAM, what kind of SPD, and so you have to verify before you enter into the system. Because the people will go into the system and take your bulb out and release to production. If you enter it's wrong, so this is going to cause a big problem for us later on. So you better be very carefully when you deal with the bulb bill of material. So who verify the bulb? After you enter into the system, who verify the bill of material? Who? Okay. After verify, everybody after have a lot of work. Yes, engineering, right? So after you enter the bulb, the engineer is supposed to verify the bulb, right? So, do you have any questions in your area about the bulb? What you would do? If you have the question, good. You have to ask the engineer. If you do have a question, stop, don't try to guess. Never, ever guessing, right? The more we get, the more we will pay a big price for the mistake. So if you don't know about the bulb before, you make sure you ask the engineer. Make sure the engineer answer you the right question. Make sure you know the engineer verify the information for you before you release. Otherwise, production S&T department is releasing production is wrong. Right? So SPD data. Who take care of the SPD data? Other, right? So SPD data, this data is only for engineering. You don't have to worry. It's been taken care by the engineering development. So the SPD data just released to production. No, right? This is the file that we do to select the DRAM, to select the PCB. You see we select the unbuffer DRAM, DDR3 and DRAM chip. The PCB is 6 layers. and this is the part method order from PCB method. It's the bill of material. Okay. Okay. So you see, above 240 pin DDR3 DRAM, 1000 megabyte and 2000 megabyte. Do you understand this? You know. What is the difference 240 pin and 184? What difference? 240 pin, 184. Good job. Good. Excellent. Good job. See? Okay. So, what is the difference? Can we use DDR1 to the same motherboard? Can we use DDR1 memory and DDR2, DDR3 in to the same motherboard? Yes. You? Can you generate?
就是现在是三代会是吗？
Say it loud, no. Correct. Good. Good answer, right? Why? Tell me why.
告诉他为什么？
Why we cannot do the same? Why?
原因就是你把这什么去拼的？
Huh? Different pin. Different pin. Right. But one different pin. This is DDR23240 pin. This is 184. The motherboard, the beam socket is for, it's helping you for DDR1, right? And DDR2. So the beam socket for this is 184, and the beam socket for this is 240. Right? The beam socket for the motherboard, DDR1 motherboard, is only 184 pin. The beam socket for DDR2 and 3 is 240 pin. The socket.
说那个历史是反常。 This is called the beam socket. What difference? Good job. Now you know. I don't have to do it. So can you teach? Can you go here and teach? Okay. You do it. This one, DDR1, DDR2 with the left.
Right. Try to write something like
P.
yeah. Okay, you go. Your boss help you. Go down. Sit down.
P 要忘了看到。
That's correct. That's okay. Don't worry about media one. Media one is obsolete. Now we need the media two. Maybe you understand, but you know, but it's my more concern. The difference is for the pin here, as he said, media two. Media two. Okay. 64 in 65 you sure? Okay. You count? Okay. That's correct. Okay. Okay, so the difference between media 1 and media 2 and media 3 is the media 2 and media 3 you have 40 pin call out, and media 1 is 184. Okay? Media 1 is 184. So now let's go this little bit hard. It's more technical. Okay? Now I know you know how to test. You know how to test, right? Yes? No? Yes? Yes? How about you? Yes? See? You know how to test. How about you? Yes? Right? Everybody know. Right? Okay, and then you know about the density development process. Now, before do you know engineering process? Okay. Okay, now you know it. Getting tired, right? Oh, crazy. Let's go over this, and then we're going to combine really quick. It's about to have okay, let's go this pretty quick. You know, this is all the spec, right? That engineering need to know. If you don't know, then you need to study harder to get to know, and I can explain to you as much as I can. On both for square 40 meter gram, this is the density of the RAM, right? 1,000 or 2,000, depending on the chip by the module size at 128 times 64 or 256 times 64. So we have different chip, you know, module size. You know, 64 times 8 or 128 times 8, DDR3 and DRAM. Okay. Arthur, explain Johnny. Take a break. Go. Take a break.
它这个就是说我们是帮他们整个40拼，就大家都知道。再一个是我们的通讯就是1级和2不带的，我们用丁5 60乘8和68乘8是一个所谓的第二是丁5。那我们再往下的话，这是它的这个版本和清楚版本，是1.01、1.02、1.03、1.04，这是它增加什么地方？到1.04的话，它已经增加了 IC。增加支持256乘8 IC， 增加支持512乘8，增加1220乘8，是它的版本和记忆。
you know, all the memory ball size is identical, right? It's supposed to be, 5,250 times 1,000. 5,000 is from here to here. It's about 5.2 inches. The log from here to here, right? Mirror the height, right? Everybody know, right? 7.1. Okay, that's dimension. Okay. The thickness, 50 plus minus 4 mil. Thickness. What is the thickness? Show me where. Thickness. Excellent. You good. Right? Thickness, right? 6 layer, 5 pieces of PCB panel. What is mean 5 pieces? This gentleman, you put your nose. What it mean here? 5 pieces PCB per panel. Recently, I tried to tell you how to read the spec. I know physical PCB, you guys know. But to read the spec in English, sometimes the headquarters release that English. You need to know because you work for, you work for a Chinese American company in USA. So sometimes you really know the spec in English. If you are an engineer, in the engineering department, we need prefer. It's better to know all language, Chinese and English, because all the document releases for everybody, not only just for China side, but for Taiwan, maybe for future, Brazil, or maybe for some other area location. So we require to read by English. I know physical, some of you know already, some of you don't. So, to answer your question, there's 5 PCB panel. What it means? Speak Chinese. Equal. Yes, one handle is equal. 5. You know too? Yes, you're right. Thank you. Okay, 6 layer ball. 6 layer ball, normally the USB is 4 layer. But the 4 memory, the better performance for the whole blocking is 6 layer. Right, 6 layer. Impedance is 40 over 60 ohm, plus or minus 10%. And the pin count is 240 pin. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 240 pin. Right? Both sides the pin. So the IC information here, 64 times 8, Samsung, 10 times 11 mm. So, Samsung is 10 times 11, that means 10, 11, the body side, the body of the IC. Okay? And it's called out 1.5 volts, 8K, we test FPGA. Right? FPGA is ball grade array. So the ball size is 106 solder ball. 106 solder ball. So it's 8 band DDR3 and DRAM base. So this is some of the sample of the IC you guys need to know. Okay? If you are engineer, you don't know this, then I don't think you
qualify for the job. Okay. Now, first of all, we do a stencil information, top side stencil, bottom side stencil, 7 mil. Top side stencil, I don't know you guys know about the stencil. You know about stencil? I should give you a tour upstairs. Stencil is the stencil like this, you know, put the solder paste on and roll it over. So it's printed the solder paste on the PCB. It's printed the solder paste on the PCB. That's called a stencil. So stencil, they open all the location on the PCB aperture. So then the machine is, the stencil is inserted into the machine, and the machine is squeezing down all the solder paste and apply the solder paste on the PCB. It's called stencil. So we can get to a tour upstairs stencil.
So this is the 8 divide ball pattern. That means every single chip, the solder ball here have it, you know, divide its duty on the chip function. On the chip function, it's have duty. 8 divide pattern, ball pattern, ball. Ball is the ball is called RNC, VSS, VDD, data body type. So this is the body of the chip, how we measure, right? The body, this one is VGA. So this is the wrist of the leg here. This is the body on the side. Okay. Here is the bum. This is the pattern, reference pattern item, right? 1. You go up more. Okay. Go down. Okay. See, VO-V7 in the top location. What it means?
I just do one sample.
Okay, the top side is called the D0 whatever BD7. Okay, that's how we call out from the board for the SMT department. So the SMT department will know using this board, using this RAM, and this is the location for this use one for the E-board. So this is the bomb, right? You formula with the bomb, and this is the memory, right? Right? I show you the assembly roll later. But did you formula with this? You do in the bomb, right? U1 is equal the body side microchip. You never see this? This is the spec. This is the spec information for the equal location of U1 on the PCB. You know about this? SMT? No? You know this? Yeah. How about you? This is the capacitor, right? It's capacitor. Register, this is the register. bump, right? This is the bump call out. So we need to make sure every single item here when we enter into the system is correct. If we visit any location, it is not correct, right? So this is the drawing. You see this? Top side, D1, D1, this is the one. So this is the assembly drawing. This is some of this, the lead capacitor, register. So this D1 to D, so the component is tested up to D7 on the top side. This is ECC. Without ECC. This is the and I don't know what's going on that. So that's the bulb. Right, that's the bulb. I think that's it. Okay. So let's go this code. This is memory architecture. Memory architecture. Go to my memory. We're going to have 15 more minutes. I go very quick on this. Okay, as you are engineering, you're supposed to know how the system works, how the memory works with the CPU. Okay, the CPU, there's have an AMD CPU, and you have an Intel CPU chipset. So, this is AMD CPU. You see, our memory working with the CPU, how the CPU affects. The memory controller have built in the CPU for AMD CPU. So they build in the CPU with the memory controller. This memory controller, its job is to interface, circuit provided interface between the CPU and the memory via the memory bus. So the memory controller circuits provide an interface between the CPU and the memory via the memory bus. Okay. So you see here the channel 2, 64-bit. This standard features server and high-end laptop. So it's also the performance by dual memory bandwidth. Dual memory bandwidth. Let's go with the Intel. You see the Intel CPU. You see the difference from AMD and Intel CPU. The difference from the front side bus. The chipset from northwest is going to the southwest. You guys should know about southwest and northwest on the CPU chipsets from Intel, right? Okay. Here the key memory signal. Key memory signal is there about 4 memory signals. Gas latency, rack, common rate, and chip select. What it means? That is the clock cycle time, right? And you write one part number. 2000 CL. Key memory signal. That's the most important in the memory, right? The memory module depends on the key memory signal. So the gas mean column address stock Okay? So guard latency. What is guard latency? It's the delay from the guard signal to when the data is available or the memory bus, right? What is the RAS, row address drop? It's a signal that's triggered the row address. So I have the explanation column. Let's go back to the okay. Key memory signal, guard latency. Okay. This is the guard latency block. You engineer need to know the difference, right? We really need to know clock latency, clock cycle, clock, right? 999. That means the first one is gas. Column address drop the signal that trigger the column address. Okay? So what it does, the last clock of this says 77 will perform better than 888 and 999. It's more reliable and more fast. I'm explaining the data. Without. Okay. Memory bus. Memory bus is link the DIMM to the memory controller. It link the DIMM to the memory controller. So you see the memory bus is linked to the memory controller from the CPU, right? So including address, control, data. So right here, the memory bus includes address line, control signal, and data line. Address line are used to identify a specific memory cell where data is stored. Control signal manage the timing and the flow of data. So let's go up more down. You see the chip, the memory chip architecture. You see the chip, right? With the chip, but inside the chip it looks like an Excel. It looks like an Excel by itself. You see, a memory chip is an array of cell width, row and column similar to Excel sheet. Similar to Excel sheet. So it depends on the chip configuration, the chip architecture. It's organized at 4-bit, 8-bit, or 16-bit. So it's different. It depends on the chip, architecture, the memory architecture. So it's laid out 4-bit, 8-bit, 16-bit. With the dual channel memory controller, they have a 264-bit memory channel, which is, triple bandwidth better. DIMM architecture. So DIMM architecture, let's say 64-bit, y equal to 8 byte. It means 8 bit equal to 1 byte in the memory chip. Okay? RAM. What is the term RAM, right? RAM is used to describe the architecture of the memory module. Bank and size. Sometimes we use it different. Right? Single RAM module. Single RAM module. 8 chip times 64-bit data path. It's a single RAM module. Single RAM. So it's dual RAM module. It looks like this dual RAM module. So it has both sides. Single RAM, right? And dual RAM. This is dual RAM module. One side, RAM 0 and RAM 1. And you can call RAM 0, DDI and with ECC. Okay. ECC memory bus, ECC. What it means ECC? ECC is error correction. ECC, error correction. So while we have the DRAM and the chip with ECC, meaning ECC is error correction. But it do have 72 bit data. So normally ECC have extra chip required to store the ECC data. So that means we have 9 chips. 1, 2, 3, 4, 5, 6, 7, 8, 9. So normally the chip in the center here is the ECC chip. It store all the data. So all the data that they can do the job like error correction. So any problem with the memory, this guy will correct by itself automatically. Let's go. And this is register DIMM architecture. This is how the register DIMM works, right? Without the register, the memory controller is not strong enough to write over 100 blocks. So meaning the register DIMM architecture is required to load over 100 blocks at a time. But with our register, you cannot do that. See, with register, the memory controller only has to write a small number of register. And each register write 9 this pin right here. One register write 1 chip, one register write 9 chip, one register write 9 chip. That we call register. So, as you know, DDR1 is about 15 years ago. It's very similar to DDR2. It's very similar to DDR2. But the core out is different, right? The DDR1 is 184 pin, but DDR2 is 240 pin, and DDR3 is 240 pin. So that's the difference. The same is 64-bit data bus. This is 64-bit data bus. But up to technology today, it's go up to 200, 400, 500, 600, 800, up to 1066, or up to 1600. So every day the speed is continue, the data race is continue to rate to the future. So before we use DDR1, we use the diesel, but the DDR2 we use the VGA. 2-bit, this 2-bit and this is 4-bit. This one is DDR1 is non, but it's on-die combination. We have DDR2, we have DDR2. Memory performance. So no matter if you use the motherboard that supports dual channel memory for the memory bandwidth, meaning if you use the motherboard with triple RAM, it can support better, it can run faster. So the faster memory clock speed, the memory system will run as stable. So the more we have a very fast memory clock speed, so the more we have a stable system. So the lower latency like this, 777 right here, which will run stable. Better than the 77 here, will run stable better than 999. You see 77 will run better than 9999. Memory latency. Okay. You guys know about the JEDEC and overclocking already. Last session I already trained you guys the difference between JEDEC and the overclocking. The JEDEC is meaning everything is go to the standard die. The spec have to go to the standard spec. But the overclocking, you can break the law and you can fork the voltage, you can fork the speed faster. It depends on what kind of overclocking product you buy. So you can manually set up the BIOS by yourself.
something like that. So that's the difference. But the JX standard, you cannot, JX standard can run over the latest value. So the JX standard can run many motherboard, different motherboard. So this is the summary. Summary is meaning for the same people, right? Super Talent ECC the best. Reach the server memory. So Super Talent server module attaches wide range server motherboard. We do 100% test for all the server motherboard, right? And we support the advent of the clock and remove the latency setting. 100% tested and with specification guarantee performance. So, okay, go up, all the way up. Okay, guys. Yes, you saw that it's not set up the light. Okay, the last thing, okay. After I'm going to show you the clock, the latency, how to change it, how to set up the dial. That's for engineering, for you to know the latency and the bonus. Go ahead and go to the dial. So go to the DRAM, bonus, set up 1.65, the SMP profile. Yeah, SMP profile. Okay, give us 15 minutes, 10 minutes, we're done. Okay, you're tired. Right. So after it's going to show you in the dial setup. The BIOS. So how to set to 999, how to set to 888. This is 1.65 voltage, DRAM voltage. 1.65, 1.65. You know, this is the Intel spec, Intel voltage. This is for 200. This is really overclocking. This is all overclocking, right? This is how power is far out. Was it? No, this is amazing. Doesn't look so good. It's okay. The next time we that's okay. The next time we can go over next session. We go more little bit detail on the memory upstairs. Right? So we go to upstairs. We can do a demo. But this system something wrong with the power. Okay. So thank you everybody here, and hopefully you can get some kind of idea. You can get some kind of idea so you can perform the job better. You can perform the job better. You can support the company better. Okay.